Hello everyone, this is Jyoti Bolanavar, Assistant Professor in Computer Science Department, Government First Grade College, Naregal. Today we'll deal with the Mathematical Logic Part 1. In this we are going to learn about what is simple and compound statement and their truth value, basic conventions or notations to represent prepositions, then logical connectives and truth table, logical equivalency, tautology, contradiction, contingency, and laws of logic with some examples. First, we'll see what is a statement or open statement and preposition. Preposition is or a logical statement is a statement which is in the given context is either true or false, but not both. That means if you given with any one statement, if at any given context, if the which results, the sentence results in either true or false, such as statements are called prepositions. An atomic or a simple statement, if the statement is said to be atomic, that means it cannot be divided into smaller statements. Next is open statement. Open statement or a sentence is a sentence which is not preposition, but we can declare the open statement as a preposition by changing the values of the variables with a certain values. Let's consider examples which are atomic statements like telephone number in the US have 10 digits. Obviously, any telephone number or a mobile number, they are having the 10 digits. Sometimes it may be true or false, but it is a statement. Moon is made in China. No, it is not made in China, but it is a statement which is results either in true or false. Similarly, 42 is a perfect square, which is also again false. And every even number is greater than 2 can be expressed as a sum of two prime numbers. Such statements are called prepositions because they either results in true or false. And these here the questionable statements like this are not a prepositions. Next, here consider an example. Determine whether these given statements are prepositions or not. Let's consider first Jakarta is a capital city of Indonesia. 2x plus 6 is equal to 0. Answer for this is, the first one is Jakarta is a declarative statement. Basically, it can be either capital city of Indonesia or not. Actually, Jakarta is the capital city of Indonesia. The sentence is true preposition. Similarly, 2x plus 6, where is actually not a preposition, it is an open statement. But if you substitute x is equal to minus 3, we will get a true prepositions. But if you substitute x is equal to 2, then we will get a false preposition. But here, unless and until if you does not replace any x value, then until that it is an open statement. Once you replace with any value, then it will become a preposition. Next, conventions or notation to represent the prepositions are usually written in small letters P, Q, R, etc. It is a convention, not compulsory. Let's consider a preposition 12 plus 3 is equal to 5. Then preposition human is breathing with the lungs, and the preposition Bengaluru is Karnataka can be written respectively as follows. First one we can represent with the P. The preposition P is 12 plus 3 is equal to 5. Preposition Q we can represent as human is breathing with lungs. Then R, Bengaluru is in Karnataka. Next, truth value of the preposition. As we said, the preposition is either results in true or false. Truth or falsity of a preposition is called truth value. The truth value of the preposition is only true, that indicate with a capital P, or false indicated with a capital F. If the preposition is true, we indicate its truth value by the symbol 1. If it is false, then by symbol 0. The truth value of the preposition can be denoted as to. So here we can consider example, truth value of P is equal to F. We can read it as the truth value of P is false. Similarly for Q, the truth value of Q is true. Here example, we need to find the truth value for this is first one, obviously it is false because sum of the angles in any triangle is equal to 360, but it is 3600. Obviously the truth value of P is false. Then what about Q? Square root of 2 is irrational number. Yes, the square root of 2 is irrational number, so truth value of Q is true. Similarly, again we need to determine the truth value for this one. 3 is a prime number and every triangle is a square. First one, truth value of P is equal to 3 is 3 is a prime number, but every triangle is not a square, so so the truth value of Q is false. Next is logical connectives and compound statement. A new preposition can be obtained by starting with a given preposition with the aid of words or phrases like not, and, if, then, if and only if. Such words or phrases are called logical connectives. A new preposition can be obtained by using these connectives are called compound preposition. A component or primitive preposition, a preposition is used to construct the compound prepositions are called component or primitive prepositions. Next, compound preposition and the truth table. Compound preposition means it is created by using the connectives. Then the truth value of the compound preposition is obtained from the truth value of its component. So we are going to construct a table for knowing the truth value of compound preposition. Such a table giving the truth value for compound prepositions in terms of its component part is called the truth table. Here we have a logical connectives. First connective is not. This compound, the compound preposition is obtained by adding the word not at the appropriate place in a given preposition is called negation of the given preposition. The notation for the this preposition is negation of P. We need it read it as not of P. For example, if P is A is a consonant, negation of P is A is not a consonant. The truth table for this one is if P has a possible truth values are true or false, then negation of P. If P is false, negation of P is true. If P is true, negation of P is false. Then you can say the rule for negation is if the preposition P is true, then the negation of preposition P is false. Conversely, if P is false, then negation of P would be true. Let's consider example, negate the following prepositions. So here 2 is a prime number, that is a basic preposition, that is P. 2 is prime number. Negation of P is 2 is not a prime number because the truth value for this is negation. The truth value of P is equal to true. Yes, 2 is a prime number, but negation of P is false. Next is conjunction. It is also called and. If the conjunction is a compound preposition obtained by adding the two prepositions by using the word and. If P and Q are the two prepositions, then the conjunction of P and Q is denoted by the symbol P conjunction Q, and read it as a P and Q. And this is the truth table. Rule for constructing the truth table for conjunction is P and Q is true if P is true and Q is true. Otherwise, P and Q is false. You can see here, these are the possible truth values for P and Q. You can observe whenever if P is false, Q is false, result is false. Anyone is false, then the result is false. Only it is true when both P and Q are true. Example here, Same, you need to find the truth value for this one. Java island is greater than Aryan island, and 2 is a even number. We can consider P as Java is island, which is greater than Aryan island. Then Q is 2 is even number. P and Q, we can represent it as false because truth value of P is true, but truth value of Q is false, so that P and Q is false. Next is disjunction. It is also called OR. A disjunction is a compound preposition obtained by combining the two prepositions by using the word OR. If P and Q are two prepositions, then the disjunction of P and Q is denoted by P or Q. This is read as P or Q. This is a truth table, and here we have a rule for disjunction as P or Q is true if at least one statement P and Q is true, otherwise P and or Q is false. That means here you can observe, in this case both are false, the result is false. In this case anyone, Q is true but P is false, but the result is true. Similarly, P is true, Q is false, but the result is true. P is true, Q is true, so the result is true here. Same here. We can observe, this is a given question. These are the statements. They either results in true or false. Let's consider the truth value of P is true and truth value of Q is also true. Then P or Q is equal to true. Next is exclusive disjunction or exclusive or antanu karibodu. In this case, exclusive disjunction is a kind of preposition where that can be that the compound preposition P or Q to be true only when either P is true or Q is true, but not both. Is represented with this symbol and read it as either P or Q but not both. Okay. Here we can observe, if both the inputs are same, output is false. If both the inputs means P is false, Q is false, so result P exclusive or is false. P is T, Q is T, so the P exclusive Q is also false. In remaining cases it is true. This is an example. So truth value of P is T, truth value of Q is T, both are T, so the P exclusive or is false. Next is implication, or it is also called conditional. Implication or conditional is a compound preposition obtained by connecting two prepositions by using the word if and then. If the P and Q are two prepositions, then the implication is if P then Q, and denoted as P implies Q. Or you can read it as P, if P then Q. This is a truth table. According to this, the rule P implies Q is false only if P is true, Q is false. In all other cases it is true. You can observe this in the truth table. Here example, the truth value of P is F, the truth value of Q is T. So F and T is T. Next, biconditional or double implication, or it is also called if and only if. The preposition obtained by combining two prepositions by using the word if and only if is called biconditional or double implication. If P and Q are two prepositions, then biconditional P and Q is if P, if and only if Q, and it is denoted with a symbol this one. And if P, read it as if P, P if and only if Q. Okay, this is logically equivalent to this statement. The truth table for double implication is given here. That is P double implication Q is, or P if and only if Q is true when P and Q both are true or both are false. That means they should have the same truth value, then only the result is true, otherwise it is false. Here you can observe here, truth value of P is true, truth value of Q is true, then truth value of P double implication Q, or P if and only if Q is true. Next is logical equivalence. Logical equivalency means if two compound prepositions A and B are logically equivalent, if they have the same truth value. It is represented by using this symbol. You can observe here we have two prepositions, that is P implies Q, and negation of P or Q here. You can observe the truth value of this column and truth values here are same, okay, so that we can say this compound preposition is logically equivalent to this. This is a simple example. You can observe here the truth value for negation of P and Q, negation of P and Q. Here we can observe first and this one, the truth values are same here, and in this case you can observe the truth values are same. So we can say that they are logically equivalent. Next is tautology. Tautology is a compound statement that is true under all the possible valuation or evaluation, or it is also called truth assignment or interpretation. Okay, in this case, if you consider any combination in the truth table, you can observe here, and this is a preposition, you can observe all the values, all the truth values are true. So this preposition we can call it as a tautology. Here similarly, the given preposition is this, construct the truth table, okay, according to the rules. Then observe here the last column for this given preposition, compound preposition, you can observe all the truth values are true. So it is a tautology. Next is contradiction. Contradiction is a compound preposition that is falls under any possible valuation. In this case, we can observe here for a given given preposition, the last column, all the truth values are F. So we can say that this preposition is contradiction. Same example you can consider here. Last column, if you observe for this given preposition, all are false. So it is contradiction. Next, contingency. Contingency is a compound preposition, the compound statement that can either true or false under any evaluation. If you consider this preposition, here you can observe in the last column, it is a mix of true and false values. So this type of prepositions truth value we can consider contingency. Here also you can observe in the last column, it contains the mixture of true and false values, so it is a contingency. Next comes laws of logic. We have 10 laws of logic here. First one, laws of double negation here. If you have a preposition P, then negation of negation P is again P. You can carefully observe these laws. Next is idempotent law. Idempotent law is if any preposition P, then P or P is P, P and P is P. Identity law, if P or F naught, that is true, is P, P and T naught is P. Then law, inverse law, for any preposition, P or negation of P is logically equivalent to true, P and negation of P is logically equivalent to F naught. Then domination law, for the preposition P, P or T naught is T naught, P and F naught is F naught. Commutative law, for any given preposition P and Q, P or Q is logically equivalent to Q or P, or P and Q is logically equivalent to Q and P. Next is absorption law. For any preposition P and Q, P or P and Q is logically equivalent to P. P and P or Q is logically equivalent to P. De Morgan's negation of P or Q is negation of P and negation of Q. In case of conjunction, negation of P and Q is negation of P or negation of Q. Associative law, according to this, P, Q and R are the prepositions. P, R, Q or R is logically equivalent to P, R, Q or R. Similarly, for and also you can do the same things. Distributive law, according to this, P, R, Q and R is equal to P or R and Q, P, R, Q and P or R. Similarly for the conjunctions. Okay. These are some examples here you can observe. This is, we have to solve this by using the laws of logic. Here first we can observe here. We have double negation, negation of negation, negation of this one, negation of negation P or negation of Q, we can say this is by De Morgan's law. Then negation of negation P, that can be P by using the double implication here. Here we can observe distributive law, you can observe here. So there is a common factor that is P, P or Q and negation of Q. Q and negation of Q is F naught. So P or F naught is P by using the identity law. Similarly, this is also one more example. Some of the laws of logic like double negation and De Morgan's associative and commutative law can be used to simplify this problem. Thank you. You can refer these books for more examples and more examples. Thank you.